the annotation thingy. Okay, and then now we continue with the next resource on the director side. It is a pool resource. As I told you, pools were always a bit, questionable when people start working with bacula. Why? Because this is the only resource, if we don't count the job defs, that are not actually something, that resembles an object in bacula. This is a resource that describes group of volumes. Why do we need them? As I told you, in general, you can have hundreds, thousands, even tens of thousands different volumes in bacula utilized as a part of a normal day-to-day routine. And it would be ludicrous if you needed to describe each one of them as a resource. So what we do, we group them into groups and describe only the group. And once an actual volume is created, it inherits all the attributes from that group. A group of volumes is called a pool. Okay? And a pool needs to have a name, of course, uniquely identifiable. It needs to have a type. By today, we have only one type of pools. Those are backup pools. And then it needs to have different attributes belonging to a volume. Prominent attribute that can belong to a volume is retention time. I told you about file retention, and I told you about job retentions, but there is a third retention, and I told you about that one. It's a volume retention. It is a time for which the records about all of the jobs and all of the files that are stored on a certain volume are kept in the database and the volume itself. Once the volume retention is reached, that records can be removed automatically or semi-automatically as with the means of a pruning action. Okay. So this is one of the things that you can set inside of a pool. You can also, as with a client, you can enable or disable auto pruning. If you enable it, each time a pool is used, at the end of that job, volumes will be checked, okay, for retention. And if some of the retention has expired, those records belonging to those volumes will be removed from the catalog, together with the records belonging to all jobs and pools connected with those volumes. And also, you can define whether or not volumes from a certain pool can be recycled. By default, they can be recycled. This value is yes. And if a volume is recycled, it means that first this volume has been pruned, okay? So removed all of the records from the catalog database, and then the volume is eligible to be recycled. Next time bacula needs a volume, and it cannot find one, bacula will, as a means of searching for a new volume, also recycle a previous one. What does recycling imply? It implies that bacula will literally rewrite that volume. It will remove all the data and rewrite the label of a volume. And from that point on, the actual backed up data ceases to exist. So with bacula, backed up data is available for a long time, for as long as it's not recycled. Once the volume has been recycled, backed up data does not exist anymore. But let us discuss pools a bit more. First, bacula was built with tapes in mind. So all bacula archives that store backed up data and together with the metadata have a format that is tape friendly. Okay, it has a header and then sequentially written bunch of data and metadata belonging to jobs. Because bacula works with tape out of the box, bacula is not overly concerned by the quantity, by the size of the data that is written on a single volume. Why? Because tapes tend to have physical limits, and once that limit is reached, it is called end of tape. It's a signal. And the tape drive will spread that signal to bacula. And bacula knows how to detect this state, and bacula will simply proclaim the volume from appendable to full. Okay? So there are certain volume statuses in bacula. Once the volume is created, okay, it is in a status new, and then once first job starts writing on it, it comes to a status called append. That means that this volume can be appended to. And as long as the volume is usable, it is in append state. Once the volume reaches the end of its physical size, like with tapes, it goes into a status full. But with disk volumes, there is no end of tape. There is no physical signal. Bacula will not be aware once the disk has reached its limits because this is just a file. Like any other file, this can even reach its limit not because of bacula, but because something else is filling it. So bacula does not know. This is why you need to contain volumes that are not tapes. Volume containment in bacula can be done using different criteria. We will discuss those criteria, and all of those are defined in a pool definition. Okay? Some of those are number of jobs written on a volume, number of logical files, number of bytes, use time, etc. Okay? But for you to understand if a volume is not a tape volume, but a disk volume, a cloud volume, or a dedupe volume, you need to contain it somehow. And for this, you need to explicitly define a limit in a pool definition. The first way how you can contain the volume is by number of jobs that are written to that volume. By default, the value is 0. The directive is called maximum volume jobs. And when it's set to 0, it means that you can write, there is no limit, that you can write as much a job as you like to that volume. When you set a limit, as soon as this limit is exceeded, that means if I set a limit to 5, as soon as bacula starts writing job number 5, the volume will be moved from status append to status used. All volumes in status used, okay, will not be appended anymore. So they are as good as full, but the soft limit has been reached, not the hard limit, okay? Once the volume has been in status use, no additional jobs can use it. And the only thing that can happen to the volume can sit there until its retention expires. Once the retention expires and once pruning kicks in and all the job and file related records and the volume related records have been removed from catalog database, volume is moved from status use to status purged. It's totally clean now. Volumes that are in status purged can be recycled after a certain period of time when a new volume is to be used. Until they are recycled, they are still usable. You can restore from them, but not directly. You need to utilize certain additional binaries, certain additional programs to restore from those volumes. Okay? If you define the pool with a certain maximum volume jobs, for example, 5, and after some period of time, you have decided to modify this value, to set it to a higher value, for example, 10. You must be aware that once you modify a pool definition, the existing volumes will not pick up the change, only the newly created volumes, because volumes only pick up from the pool definition once they are created. The existing volumes will retain the old values, and if you want to change them, you need to explicitly change them volume by volume. There is a specific bconsole command called update, and you can say update volume equals, and then volume name, and what to update, what limit to update to what value, okay? For example, for retention, you say, maximum volume jobs, you say update volume equals, then the volume name, max volume jobs equals, and then the number, okay? This is simply because of the fact that only newly created volumes inherit the pool. So you need to be aware of it. Okay? Also, one interesting fact about maximum volume job. This is possibly one of my favorite volume limiting techniques. I just simply, with all the volumes apart from the tape volumes, because all of the other volumes are literally some type of files, and files can be unlimited in number. They cannot, but on the modern file system, it's almost as is. So what I advise people mostly, if they are not using tapes, is to limit the volume by jobs and only allow one job to be written per volume. It eases the management of volumes. It eases later disaster recovery restores. It's much easier to scan a volume that has only one job written to it, and you know exactly which volume to scan, etc., etc. But again, this is again a matter of a personal choice. Okay. Next way how you can contain the volume is by number of volume files. No, this is not the number of files written by a job. No. Volume files are something called logical files. Logical files are special entities created by storage daemon in order to be able to navigate through tapes more easily. Logical volume files are actually places in between two end-of-file marks written onto tapes, so tape drives can scan through tapes quicker, rewind and wind the tapes in between those two marks. Those marks are written into tape, and together with the other metadata are also recorded in the catalog. And the size of a logical volume file can be configured. We're going to discuss it when we discuss storage daemons. In this case, instead of limiting volumes by the number of jobs, you can limit the volumes by the number of those end-of-file marks that are written onto the volume and into the catalog. Okay? By default, it's 0. It means no limit. If you prefer to use this approach, you can use it. Never used it myself, but who knows? People sometimes want to contain those volumes also like this. Also, for you to understand, because there are multiple ways to contain volumes, it doesn't mean that you can use only one. You can define all of them. The first limit that is going to be reached is going to make the volume mark as used. Okay. There is also a way that is pretty natural to majority of people, and that is to contain the volume not by number of jobs or logical files, but by number of bytes that is written to the volume. That makes perfect sense if you would like to see a lot of files of equally the same size. Again, to me, it doesn't make much sense. To me, it's much better to contain volumes by job count. But there are different flavors here. For you to understand here, by default, this is 0, so it means no limit. If you set a limit, each time bacula writes certain quantity of data into a volume file, it will close that file, mark it as used, and open a new one. Okay? Everything else applies here. And for you also to understand, this way of containing volumes work only with disk volumes. With dedupe volumes, and especially with cloud volumes, it doesn't work so good. Okay? So you can consider using this one only with disk volumes in bacula. Also, volumes can be used in regards to the time they are used. Some people, for example, say, write to this file only for 1 day, and then open a new file. Then you can use volume use duration, set it for certain time, and as the large job and the volume will be closed as soon as that time expires, counting from the first time it was written to. Okay, by default, again, no limits, and you can set it to anything. Of course, you can use time definitions. You can say 1 day, 1 year, 23 hours, 22 hours, 15 minutes, whatever you prefer. Okay? Just for you to know that there is a possibility. Again, you can use multiple approaches. You can use a single approach. Whatever you choose to use, please use at least one on disk, cloud, or dedupe volumes. Because if you don't do so, volumes will become indefinite and they will be hard to handle. And you know what can happen if you lose If your volumes are relatively small, for example, extreme example that I like to use, you have only one job on a volume. If something happens to that one file, you have an issue only with one restore. But if your volume is huge, you have hundreds of jobs, thousands of jobs written to a single volume. If something happens to that file, you have 1,000 restores jeopardized. Okay, that's the first thing. The second thing, volume are recycled faster if you have less data on them or use them for a less period of time, etc., etc. So management of volume is much easier if you contain them to something that is more frequent in change or smaller in size. Okay. In any case, each of the volumes, if they need to be pruned and recycled, need to have retention defined. By default, volume retention is set to 1 year in bacula. You can set it to anything else. Once you set it, please make sure that volume retention is the longest. Because when you perform automatic pruning, if you clear volume records, it will automatically clear all job and file retention records. Okay? For you to understand also, when you perform pruning, if you prune jobs and files, if the job that needs to be pruned is the only full backup of that belonging to that backup job definition, it will not be pruned. But if that job is connected to a certain volume and the volume is pruned, it will be pruned. So volume pruning and volume retentions are the most potent ones. They can remove anything. Okay? They do not even they don't even consider backup sequences. Okay? In regards to the pruning, it's needed because once you remove the records, you make room for new records in backup database, so your backup database doesn't grow indefinitely. And also, only volumes that have been pruned are eligible to be recycled. When a volume will be recycled, okay? So when backup needs a volume, a new volume from certain pool, okay, let's say all the others have been used, what bacula will do? It will first try to find a volume that has already been recycled. If that volume does not exist, it will try to create a new volume. If it cannot create a new volume, for some reason, we'll discuss some of the reasons, then bacula will try to get a volume from additional pool that's called a scratch pool. We'll discuss that one. And then, if it cannot take that one, then it will recycle. So recycling is the last resort. Why? Because bacula tends to keep data available for as long as possible for a restore, even if it's not in the catalog. Okay? What is a scratch pool? A scratch pool is a special pool, okay? It is predefined, it is called scratch, and this pool is used by default with all other pools to get new volumes from, if there is no eligible volume or a new volume cannot be created. If you don't have a scratch pool defined, bacula will simply, and cannot find a new volume or recycle one, bacula will simply halt, issue a note that a new volume needs to be labeled and the job will be paused. Okay, will get stuck. And one more thing before we jump to catalog, you can also contain the number of volume inside of a pool. That is called maximum volume number. It's not listed here, but we'll see it later in examples. So you can also contain the quantity of volumes inside of each pool. You can do so or not, depending on your needs. It is better to do so, you have better control, but then please be aware that bacula can only recycle volumes that have been pruned, and volumes that are pruned or purged and then made clean can only be purged if they are in status used or full. If a volume, for some reason, has a miscap, it's proclaimed as in status error. That volume will not be considered to be pruned because you need first to understand what happened and then manually change its status. Those volumes will take one of your maximum volume number count. So if you have a lot of errors volumes, it might happen that you will not be able to create new volumes inside the book pool if you have created maximum volume count, maximum volume number limit. Just for you to be aware. In that case, you can always manually create new volume with the label command, or you can just move some of those volumes from error into used. Depends on the use case. But if you're doing so, if you're moving volumes from status error to used, please understand why are they in error, okay? And this is all about a pool resource. Now, a catalog resource. A catalog resource, I told you, needs to be defined on a director side to point to a catalog that is to be used by certain clients. You can have one or more catalog resources. We do not suggest using multiple catalogs, but it's possible. You define it by defining its name and then parameters on how to reach the SQL database. If it is a local database, you need only to have a name of the database and the username. Even the password is not needed because you're connecting to a local database through a Unix socket. So in general, that type of communication is not password protected. But if you prefer to use a different approach or even a different name of a socket, then you can define a DB socket parameter, and that is a path that points directly to a socket that is to be used. By default, it uses a socket which corresponds to the type of the database. I forgot what was the name of the socket. It was this SQL, but part of the socket. But anyhow, you can double check. You can also connect to a database not using the Unix socket, but through network. If you're connecting to a database through network, that means that that database can either run on a separate host or on a DB cluster, or it can run on the same host, but you do not prefer a socket connection, but directly networking connection. In that case, you need to define a DB port and a DB address. If a port is not defined, default port number will apply, okay, depending on the type of the database, okay? And if you have a remote access, you will most probably need a password, okay? When you are defining a catalog entry and it is not a default database that was installed during the process of installation of Bacula, you will most probably need to coordinate your efforts with the DB administration, DB admin team on board, because they know all of those fancy things like socket, DB sockets, DB ports, addresses, a database name which they created for you, username and password, and they are also in charge of setting up the database authentication scheme on the other side. Okay. As I told you, once more, if nothing is configured or reconfigured by default, Bacula tries to connect to a database of the same type that corresponds to the package that has been installed. So if you're installing Bacula PostgreSQL package, the director will try to connect to the PostgreSQL database on the local host using the Unix socket. And the database name will be Bacula and the username will be Bacula, okay? Next resource that we are going to discuss about is the messages resource. And this one is pretty important and pretty useful. Why? Because messaging resource is a resource that describes how Bacula handles events and logs, okay? Messages resources can be pretty comprehensive to configure. Luckily, you have them pre-configured once you install Bacula daemons. So all you need to do is copy the kind of configuration and edit it a bit. And there are three types of directives they use. Regular simple directive, keyword equals value, and two types of destination directives. One is a destination equals message type list, and the other one is more complex, destination equals address equals message type list. It depends on the type of destination. So these are different destinations for message. So simple keyword equals value is the name. Name equals and then the value of a message resource. You understand that one. Types of destinations are as follows. You have a destination called mail. This is a complex destination type, so it needs also an address. This destination is activated for all the messages that belong to a job, and it will be sent to a specified address. Important thing about this message resource is that it will send emails only once job finishes, so it will not send message by message. Okay? So what you say is mail equals and then mail address admin at, I don't know, corporation.com, and then you said equals and then the types of messages that are going to be sent there. About messaging types, we are going to discuss a bit later. So this sends out all the message types to a specified email address. There is also a message destination called operator. It behaves exactly the same as mail. It will ship a message to a mail address, but unlike mail, it will send a message as soon as this message has been generated. It will not wait for the end of the job. These are sent mostly to the operators, and mostly these messages are messages that will notify the operator that the job is stuck. For example, a volume is missing and a new volume needs to be labeled. Okay? Then there are two modifications of a mail resource, mail destination. One is called mail on error and mail on success. They work exactly like mail, but they will send out messages in the first occasion only if job fails, in the second only if job succeeds. Okay? And those are all mail related. Then we have a destination called console, and this does not require an address. This destination directs the messages resource to send out different message types directly to console. Those are the ones that you see when you type a message command on a console and then flash the message queue. Then there is a catalog that will send all the messages directly to the catalog for logging. Okay? There are standard error, standard out, and syslog. Those are system utilities that you can use. Standard error and standard out are standard system devices used to handle messages of errors or different outputs. Syslog is a syslog device, syslog daemon listening. So if you send something to syslog, it will be shipped out to a syslog daemon as you have configured it, and it will be shipped out with facility code log daemon and level log underscore error. So you need to catch it from the other side in syslog and then treat it accordingly. Then there is something that is pretty exciting, but not so much if you see how it works. It is file destination. This means that every message will be sent to a file. What is the problem with this destination? This destination overwrites one message with the other. So it will always show the last message, nothing else. So if you want to see all the messages, you don't use file, you use this one. It is called append. Append will add to a file, but it will not remove the previous messages. This is useful to create bacula logs, okay? And there is one message resource that is mostly used on remote daemons. It is called a director, and it will send, and it also takes an address, the name of the director, and it sends all the messages of certain message type directly through the communication link that was opened during the execution of a job to the director, okay? For you to understand, nowadays, file daemons only have this as a message destination. So file daemons will report anything to the director, and that's it. You will not find any logs on the file daemon itself from Bacula or syslog or anything else. Storage daemons, for example, by default send everything to the director, but also create a log. Why? Because something can happen on a storage daemon, and the communication between the storage daemon and director might not be working, so we can use that log now. Directors themselves log messages differently depending on your needs. By default, they create file, they create everything, they send everything to the catalog, and they send everything to the console. But you can also enable mail and everything else. They send everything also to the mail destination to a mail address route at localhost. So those were messages destination. Depending on which destination you have activated, those messages will be sent there. But which messages? Only the ones of a type that you desire. There are different messages types. Here are they listed by the level of severity, okay? From the severest ones to the least severe. So, sorry. So if you say message type terminate, it will only send messages generated when daemon shuts down, not anything else. If you want to send different types, you just list them one by one with comma. Also, there is a special message type called all that will send all of these messages. And sometimes, because it is easier to send all and then just forbid some messages or filter them out, we have a possibility that you can negate certain message types with an exclamation mark. So if you say all and then comma and then not restored, it will send all of these messages apart from list of restored files to the destination. So this is how it's configured. Okay? Any questions? Before we wrap up with the messages resource, there are directives that I told you. There are simple ones, keyword equals value, that can be used. Those are the name of the resource, of course. It needs to be unique for every messages resource because you use it inside of a client, okay, and inside of a director, inside of a job also. And there is two additional message resources. Those are mail command and an operator command. Those are actually instructions on which command bacula needs to execute to send emails to a mail destination or an operator destination. For a mail command or an operator command, you can utilize any of the mail client commands that you have on the system. If you don't have any, we have one pre-shipped with bacula. It's called BSNTP. It's quite rudimentary, okay? But for you to know, this command takes the variable substitution that we've seen before, okay? So in this specific case, if a mail message has been triggered, it will trigger the BSNTP command that will send an email using a host mail.sybil.com, okay? And using this header and this subject, okay? It will send complete job log to the address that is listed in a mail resource, okay? Operators command looks similar like a mail command. In a mail command, character substitutions apply, so you can list the job ID, you can list the job name and everything else. They are highly dependent on the way how your email system is set up. So your mail submission agent or your mail transport agent need to be configured and your command needs to be available to use those, okay? If this submission method used by BSNTP does not work, feel free to use some other commands for submission of emails. When setting up email delivery with bacula, you will need to work closely with your email administrator in order to understand all the niceties of the email transport system at your side. So a bacula director can send out emails automatically, okay? And this wraps up our configuration section in regards to the director. Are there any questions? So we have reviewed all the resources that can be defined inside of a director configuration and all the major directives all the approaches that major approaches that need to be used and carefully considered when you're configuring. Now we are going to perform the same for the file daemon and the storage daemon. We will jump at the file daemon configuration. So now we are discussing about the resources that you can configure in a bacula-rd conf file on the file daemon side, okay? Before we start with that, some overview of the file daemons. So file daemons, like the director, like the storage daemon, run as an attendant service, as a daemon, okay, on your host. They need to be installed on every host that is to be a source of backups. So a lot of different platforms need to be supported, okay? And we have them. In general, you need to install one file daemon at least that every machine that needs to be backed up. Some people even install more of them, but then they need to run on a different port, okay? And file daemons, unlike the director, need to run under super user privileges, okay? So they need to run as a root user on Linuxes or Unixes, or a system administrator or system user on Windows. And on Windows, they're installed as services and run automatically. And file daemon is the only Bacula component that needs to be deployed quite frequently. Not on every host that you back up, because virtual machines can be backed up without it, but quite frequently. And for you to understand, when you have Bacula running certain version, file daemons can be running the older version of Bacula, and it's still interoperable, okay? Only the storage daemon and the director needs to run on the same version of Bacula. Also, it is possible for you to connect file daemons running a community version of Bacula into an enterprise Bacula architecture. It will work. Thus, we have implemented this approach because file daemons are broadly implemented, and once you need to perform an upgrade, it would be ludicrous to assume that you will be able to upgrade all of the file daemons at one go. Okay? The most important resource in a file daemon configuration is called a file daemon resource or a client resource. It's totally the same. Like you have a storage in an auto changer, pointing to the same thing, you have a client or a file daemon. It is the same, and it describes the client itself or the file daemon itself. It needs to have a name. This name should be unique on the file daemon, and this name should not, in general, correspond one-to-one to the name as described in the client resource on the director side, but it is a good practice to be so. Okay? If you plan to run your file daemon on any other port apart from a default port 9102, then you can specify it here. For this example, this file daemon runs on a non-standard port 8102, okay? And you need to have a working directory defined, and you need to have a process ID directory defined, like with director daemon, if you remember. Of course, you have maximum concurrent jobs set here, and you have something that you have not seen on the directory. It's a plugin directory. Actually, this needs to be defined because in this directory, Bacula stores all of its enhancements. When you install a plugin, it will be installed there. And the file daemon needs to be aware of these directories in order to use the plugin. To be honest, nowadays we also have director plugins. So we need to have a plugin directory for a director also in enterprise, but that's, that's relatively recent. Okay? If that is the basic configuration of file daemon. If you want to change something, there are additional things that you can modify. For example, if you want to run a file daemon, bind a file daemon onto just a certain IP address, then you need to define a FD address instead. If you don't do so, it will bind to all of the IP addresses. Here, as a parameter, you can say IP address or a host name, as long as it can be resolved. Then if you want to run it on a different port, you need to define FD port as you've seen it. And as on the director side, there is also a heartbeat interval, but this time from the file daemon's perspective, again, the same thing apply. If you have some overzealous firewall in the network that kills connections that are idle for relatively long time, by default 300 seconds, then you add this directive and put it to a lower value than 300, thus keeping your your TCP IP connections a bit livelier. Okay, and once you define it, each time this timer is reached, file daemon will send out a special message to the director, nudging it, and also to the storage daemon, nudging them to reply back. Okay, so this is a regular heartbeat. Also, since file daemon needs to communicate with the storage daemon by opening that third connection, you can define the connection timeout. Okay, and you can say, if the storage daemon does not reply to my connection attempt within this time, by default it's 30 minutes, I will proclaim the storage daemon as dead and kill the job. Okay? So once a director wants to initiate the job, it will nudge the file daemon, say, hey, connect this storage daemon and start the job, and it will also nudge the storage daemon. But once the file daemon opens the connections to the storage daemon, if the storage daemon does not reply in 30 minutes, the file daemon will nudge the director and say, this job cannot be run. Okay? It's canceled. And there is a value which I've rarely seen configured. It's called maximum network buffer size. By default, it's 64 kilobytes, and it can be adjusted in steps of 512 bytes, and it should be adjusted only if you think it is used only with the communication with the storage daemon. So if you have a network that allows for a bigger payloads to transfer, like jumbo frames, then you can adjust this one. Once you adjust this one, it will also nudge your kernel TCP/IP stack and try to send bigger payloads inside of one package. Okay? If you see some performance issues with the default size, you can even try to narrow it to make it shorter. In general, if you are satisfied with the throughput of a communication between your file daemon and the storage daemon, do not play with this one. But if you decide to play with this one and try to use a bigger value, but beware, hard-coded limit is 1 million bytes per packet, so you cannot go above that one. So if you try to make it bigger, then be aware of that one. So if something goes awry, you know that you have been messing with certain kernel parameters, not kernel, but TCP/IP stack parameters. And B, if you set it here, please set it also on the SD side. Okay? And of course, there is the omnipresent maximum concurrent jobs. This one defines how many jobs you can execute in parallel on this specific file daemon, seen from file daemon's perspective. Okay, by default it's 20. You can set it to 1, and then it will be sequential. You can set it to bigger value, lower value, depending on your needs. Okay, again, it can be set all around the board, so I will not keep repeating myself. So this is a concurrency setting that you can find all over the place. Apart from these settings, some things also additional can be set per file daemon that we are not going to discuss it, just mention it here. File daemons can perform data and transport encryption. By now, out of the box bacula, all bacula daemons communicate using encrypted communication. Complete encrypted communication circuits using those passwords as initial keys to share an additional pre-shared key, okay, during the authentication. All the communication is encrypted, but if you are extra paranoid, you can build another layer of encryption above that one using TLS and pre-shared and public key infrastructure, Okay, it is possible. And also, what file daemons can do, they can encrypt all the data that are backed up directly as they are outbound of the file daemon. So you can encrypt data directly from the file daemon, so no one else will be able to restore that data apart from that same client. Okay? So you can encrypt the data at source. This is something that can be set up, but we are not going to discuss it. Also, you can set up your file daemon to listen only to certain uncertain addresses, group of addresses, and certain IP addresses by using the FD addresses, so plural form of the directive. It's a sub-resource. Okay, and also nowadays we have worked a lot on the security because file daemons have a lot of permissions because they run as a super user. We need to contain them somehow. There are extensive options of what you can do in your bacula daemon configuration to contain your file daemon. To allow them only to read from certain directories, to restore to certain directories, to allow them only to run certain commands, to execute certain commands, not to execute others, etc., etc. Different permissions. So there is an extensive way of things that you can do to contain your file daemons. We are not going to discuss them. I'm just mentioning them here so you are aware. You can read about those if you are interested. And as you have expected, this leads us to our next exercise because now we have defined a file daemon configuration, so we are now able to add another client to our bacula virtual environment. So you need to prepare a second client that is that second VM that you have installed. You need to install the file daemon onto it, and you need to configure it so it communicates with bacula director. It can be used with bacula director. Please stop the firewall if the firewall is in the way, okay? So modify the configuration, and once you have everything set up, then you need to create a new job and execute it on the newly created file daemon, okay? And once you perform a backup, then try to perform a restore, okay? And take a screenshot of a status client command that can be used from the director to nudge the file daemon, and if the command executes properly, we will know that your file daemon has been properly configured. Okay? Please be aware that during execution of a backup job, you might end up with a storage-related errors. This has to do with the fact that file daemon needs to communicate with the storage daemon directly to run the backup. If it's not possible to do so, you will be informed. Most prominently, the file daemon needs to know the IP address of a storage daemon, and that means director needs to tell them. So you need to double check the storage resource definition on the director to see whether or not the address is properly set, because that is the way the director knows how to reach that storage. Okay? And this will end our session for today. Starting tomorrow, we will start with communication of a storage daemon. Okay? With the configuration of a storage daemon. So if there are no questions, you are free to disconnect. Thank you very much for your attention and for your time invested in this course. Tomorrow morning, 9 a.m., the course continues. Arno will be with you tomorrow morning. I have some engagement, so I will be with you tomorrow afternoon. But if you have any questions, please feel free also to ask Arno. No problem there. Arno will be available also an hour or so before if you have additional questions. For now, if you don't have any more questions, please feel free to disconnect, okay? If you do, I will be online for a certain period of time to listen to your questions, okay? So I wish you, let me just stop the screen sharing. So we will continue tomorrow with the storage daemon configuration. I wish you a great reminder of a day, great evening for you, Young Joe in Korea. And yeah, thank you once more for being here.